Hello, welcome to your second video on representation and probability. Let's go back to the problem we had with 15 students, 3 of whom study art, 6 biology, and 1 studying art and biology. This is the Venn diagram we created in our last lesson or last video. Let's use this one to ask a couple more questions. First of all, using this Venn diagram, find this probability. Okay, so let's see how it went. As you may remember from a lesson before school was over, we had this symbol here. This symbol means given that, or also known as conditional probability. This means we're looking for the probability of B happening given that A has occurred. So here is A. So instead of looking at our whole group of 15 students, whenever we see this symbol, we look at only this small subgroup. And in this case, it says A, so we're going to look at only the A group. And here it says we're looking at the B students out of the A group, right? So the biology students out of the art student group. So here's the art student group. Here's the one student who is in biology and art. So our probability here is 1 out of 3. There is one student who is a biology student in the art group. So now let's look at another question. This one says, find this probability. So try this. Okay, in this one, we are still looking at the art group because it says given that they are an art students, so still looking at these 3. And from there, we're looking for the students that are not biology students in the art group. So here's the art group. This student is a biology student. These 2 here are not biology students. So therefore, this time, this probability is 2 out of 3. 2 biology students, 2 non-biology students in the art student group. Okay, so looking at other representations, we've talked about sample space diagrams as being another way of representing probability kind of information, and tree diagrams. And last time we looked at tree diagrams in more detail. Now we'll look at them again. So you may remember this problem about Raghav, who is a keen member of the school archery club, and this tree diagram represented him taking 2 shots with his arrow. He can either hit the bullseye or miss, and then he takes another shot when he can hit the bullseye or miss again. So that's what we had before. Those were called independent events because what happened on his first shot, whether he hit or missed, had no impact on the probability numbers on his second shot. Notice his second shot probability numbers are identical to the first. That's we've done that problem. So now let's change it around just a little bit. So now all that's the same, except now we assume that each shot is dependent. See, I crossed out that, dependent on the previous shot. So now, let's say if he hits the bullseye on the first shot, then his next shot is 0.85. He has a probability of 0.85 of hitting the bullseye on the next shot. So in other words, if he makes that first hit, he feels more confident, and therefore he has a higher probability of making the bullseye the second time. However, if he misses the bullseye on the first shot, then his next shot has 0.75 probability of hitting the bullseye. So now if he misses, his chance of hitting on the second shot has gone down from 0.8 to 0.75. So that miss makes him lose a little confidence, and now it goes down. That's probably more real to real life, that what happens here affects what happens here. So let's see if you can fill in this tree diagram. Fill in everything, but let's, in this question, let me ask you what goes here, here, and here. Okay, let's check. So we have 0.8, 0.2, those are the original on the first shot. Then on the second shot, if he makes it, probability goes up of making the second one, and then there's a smaller chance of missing. And then if he misses on the second shot, smaller chance of hitting, and then bigger chance of missing. So those are the numbers we're looking for. Now let's use those to find this probability here. Okay, so the probability he hits the bullseye exactly 1 time. So first thing to do when you have tree diagrams is say, well, which paths lead to this outcome? When does he hit the bullseye exactly 1 time? Well, let's say he hits it and misses it. Following that path, he hit the bullseye once. Or there's another path, right? There's a path where he misses it and then hits it on the second shot. So there are 2 paths that lead to this situation of hitting the bullseye once. So here are the 2 paths. There's probability of hitting and then missing, so hitting and then missing, or, this means or union means or probability of missing then hitting, so missing first then hitting. So 2 paths, and they're represented here. So as you may remember, when you follow a path in a probability tree diagram, we just multiply the probabilities along the path. So hit miss, we're going to multiply 0.8 times 0.15 right here. Or always means you're going to add, we're going to add the other path. The other path is 0.2, 0.75, so you multiply those two. Okay, so you do that, get the numbers, you get those two values, you add them up because each path must be added up, and you get this total probability. So I hope that went okay, considering we did the similar thing in the last video. I hope you were able to figure that out. If not, study it carefully, make sure you understand. Okay, let's look at another one here. Same situation, new problems we're going to ask you. So let's say we represent the selection of one student using a tree diagram. So now we go back to this biology and art student situation in this Venn diagram, and we're going to use a different representation, a tree diagram, to represent this. The first top part of the tree diagram is presented here for you. So we have a probability of getting an art student and then a biology student out of the art group, right? So here is 1 in 5 students are art students. Is that right? What do we have here? There are 3 art students out of the total 15. So 3 out of 15 reduces to 1/5. So yeah, 1 in 5 students are art students. And then if you follow it further, of those art students, biology, given that it's an art student, so of the art students, there is 1 student out of the 3 who is a biology student, and 2 out of the 3 who are not biology, right? So now what would the bottom part of this tree diagram look like? See if you can draw it in, and let's compare it to the answer in a moment. Okay, so here we have it. If this was a probability of getting an art student, this is now a probability of not. See a little symbol there? Probability of not. That means A naught means not an art student. So if 1 in 5 are art students, then 4 out of 5 are not art students. And then if you've chosen a student who is not an art student, the chance of them being a biology student is 5 out of the not art group, which is all these students out here outside of the A circle. So 5 biology students in this part here, not all 6, but just 5, because this one is an art student. So 5 here out of all these students on the outside of A, which is 12. So 5 out of 12 is there. And then if you chose not an art student, and then we're looking for not a biology student, so it's not arts, so outside of this circle, and then not biology also, so it's outside of both circles. So it's those 7 remaining students that are both not art and not biology, so 7 out of 12 students. 7 out of the 12 non-art students. All right, so that's a little bit complex, I have to say, but if you were able to come up with that, or if you're looking at it now and you understand what's happening, what's being presented, good work, because you have a good understanding of all these details of probability we've looked at so far. So now that we have that tree diagram, please answer these probability questions. First of all, it's going to show along that branch the probability using the multiplication rule. So probability of art and biology, because we're going art and biology, you multiply the two, probability of art times probability of biology given it art, and you get 1 out of 15. So that, notice that 1/15 is just that zone there. So see if you can fill in the rest of these paths here. What are the final probability numbers along each path? Okay, check your work here. Here we have them. Double check all the symbols, see if you understand what's happening. The key thing now that we have these numbers is to really compare them to the Venn diagram and notice that the tree diagram and the Venn diagram are just 2 different representations showing the same thing. So let's check. So this 1/15, the intersection of A and B, right there it is, there's the intersection. And then this one here, the intersection of A and not biology. So here's A, but not biology is there, and we have 2 out of 15. And then the third one is A naught intersection B. So that's the things that are not in art, but they are biology. So non-art students that are biology students right here. There's the 5/15, which can reduce to 1/3. And finally, probability of A naught intersection B naught means students outside of art and biology, and there's your 7/15 there. So really important, there's so many important ideas here, and they all come together. How the Venn diagram and this tree diagram, they're all related. Okay, so let's continue. We did this problem last time also about the CAS project, and we followed all the paths to their end, and we got all the probabilities. and we found a final probability of winning this competition. Let's take a look at this CAST project with a slight change to it this time. So read the top here, find the change, and let's see if you can fill in what numbers should go on these three top branches. Of course, fill in the rest of this here, but I'm going to check for your understanding by, no, let's go to here. I'm going to check for your understanding by looking at this middle one and these three here. Okay, let's check our work. So there is all the numbers we should have, and the ones I was checking here in this question were these three. So notice that in this case, something happens. The dice are not replaced in the box, right? Before they were replaced, and now they are not replaced. So notice if you go back, when the dice were replaced, the bottom of the fraction always remained the same because there's always the same number of dice to continue. But now the number of dice was reduced each time. So we started with 100 dice, but you take one out, and now there's 99. See, 99 left. And again, you take one out, 99 is the bottom of each fraction because one die has been removed, and therefore that's gone down. So for example, if you took a red first, and now you're taking a red again, we have now, there was 50 red in the beginning, now there's 49 red left, and there's only 99 total left, so 49 out of 99. So check all those numbers again, make sure you understand. And let's find these probabilities. So try A. Okay, so A represents drawing a red one first, and then red again. And it has the given that symbol here, red, given that red was drawn first, right? So basically means red and then red again. So you multiply that path there, and you get this value. How about B? In B, now we're following the path of blue and blue again. So there's the probability. And now try C. In C, we're following the path of getting a green and then a green again. So there's the final answer for that. Now, if you remember, the rules of the game are you win if you have two of the same color. So the probability of winning, like we did before, you just add up the three paths that have a winning situation. So add those three up, and there's your total chance of winning. Okay, one last one for you. Try this one. Draw a tree diagram and then see if you can answer the probability question it has here. Okay, so here's the tree diagram. Again, now this is not independent. Again, last lesson we had independent events where something happened and then the probabilities did not change. But now when something happens, the probabilities do change because one thing has been removed. So here we see 18 on the bottom, here we see 17, there's one less. So here's the full tree diagram, check your work. And now here's the work for solving the question that was asked. It has been done two different ways. Take a look closely, maybe pause the video, take a close look at both ways and make sure you understand both approaches. And finally, I will leave you with one last question, is this one. The tree diagram is started for you with some values in it. All the information is here. And let's see if you can solve question B and C. So let's check. Here's the full tree diagram. Here's B, which is basically two different paths. And then here's C. C is the tricky question where it asks you to find a probability, and it says, yeah, so it's that one is a conditional probability. So take a look carefully what happened here, because basically it says given that Mark chooses a gray shirt, so that means gray shirt becomes the bottom of the fraction, and then we're only looking for the net shirts that are gray out of only the gray shirt group. So that one is the kind of question that most students find a little more tricky. Make sure you take a look and make sure you take a close look at that and understand the details there. All right, leaving you with one challenge problem. This is a good one, and it is going back to our problem with the taxi cabs. We will let's see. Okay, so give it a try. This one's quite challenging. See if you can set this up and then calculate the probability. Now let's check our work. So here's what the tree diagram should look like. Here's the actual color of the taxi. Here's the color that the witness identified. Here's all the paths. And we're looking for the probability that it was yellow, given that it was identified as yellow, because we did know that the witness said it was yellow. So we're looking at what's the chance it actually was yellow based on that they said it was yellow. So the paths that say it was said it was yellow are this path and this path, which means it was actually blue, but he said yellow. So look at the answer here. Check the answer carefully. This is a tough one. I'm glad we came back to it though. Great problem. Good job.